All right, everyone. Hopefully everyone's doing well, staying safe and healthy. This video is going to go over the SAT questions for the exponential and logarithm test coming up. All right. So let's start with number one. Number one. All right. This is looking at four types of savings accounts and which option would yield exponential growth of the money in the account. All right. So again, if you're thinking about the formulas we've been using, right, this would be the amount at time t is equal to the initial amount times 1, and I talk about growth, so plus your rate raised to a power of t. So that makes it exponential. All right, now if you look at questions 1 and 2, or sorry, answer choices A and B, they're very similar. The only difference really is that they're saying you're going to add $100 also to the value of the account, but this is trying to mislead you because if you see here, it has percentages of the initial savings, all right, and ultimately exponential, when you talk about percentages, it's percentages of whatever value of the account, whether it's each year, each month, that they're going to multiply. So they're going to, these answers are trying to trick you, and they're going to be incorrect. If you look at answer choice D, they're just adding $100 to the value every year, right? And so that's not going to be exponential. That's going to be linear. So that's wrong as well. So the only one that's truly showing exponential growth is taking the current value and increasing it by 1% each successive year. So C is the answer for number one. All right, let's look at number two. Now, number two is going to use somewhat that formula we did for number one, except this one is talking about the population of a city is decreasing. All right, so when you do that formula for decreasing, you're going to have a very similar formula, but it's going to be subtraction in the parentheses. So my first thing that I notice is that it's talking about 10% decrease every 20 years. I'll get to the 20 years thing in a moment, but if they're talking about decreasing by 10%, then I'm going to write 1 minus 10%. Okay, so that's going to give me 0.9 in the parentheses. So before I even go any further in the problem, I'm going to cross out B and A because those don't have 0.9 for the inside of the parentheses. Now, the difference between C and D is what they do with that 20. Because they're talking about decreasing 10% every 20 years, that's over the life of the 20 years that they're talking about the population decreasing. You're going to actually think of this as dividing it over that time. So that's why it's going to be division, or D, for the answer for this one. Okay? All right, number three. Now, number 3 and 4, you're going to see are the same from the same problem, just asking two different questions. This analyst is using this equation to model the value of a stock after T weeks. So it says, what is the value for R? Now, again, that R in the parentheses we've been using is 1 plus or minus the rate. And because the value of, this one is going to be subtraction, because it says we'll lose 28% of its value each week for the next 3 weeks. Because it says lose, that means it's going down, so we're going to use subtraction. So I'm going to do 1 minus that rate of 28%, and when you subtract that, you get 0.72. So this is the answer for R. Now, same problem, number 4, but this time it's saying, how much do we expect the stock to be after 3 weeks? Okay, so I'm using this formula, but I'm going to replace R with what I just found, which was 0.72 to the value of T. And T is in weeks, right? T weeks. So we want 3 weeks. So to do this, you're going to do 360 times 0.72 to the third power. Okay, now you guys, if you have a calculator, you go and pull it out. What I like to do, since we're doing everything remotely, is if you're using a laptop, Chromebook, whatever you have at your house, what I like to do is I like to go to Desmos. And so I can type into desmos.com, just hit start graphing, and you can type literally that exact thing in. So 360 times 0.72 to the third power. When you do that, it gives you your answer of 134.37. So that's going to be my answer, $134.37. And it says to the nearest dollar. So if this was really the SAT, then I guess when I round it, I would be $134. Go and do that. All right. Again, if I do make you guys do what they would call a grid answer, student response, obviously the test is going to be multiple choice, so I just gave you some options to choose from. Okay, number 5. Now, number 5, a little tricky here. That's why I put this on the review. It is an exponential function with 2 to the x power plus 1. Again, if you use Desmos, which you know I like to use, you can go ahead and just type that in first to see what that looks like. 2 to the power of x plus 1. So 2 to the power of x and then plus 1, so you can see what it looks like. All right, but it's not saying what does that look like. The problem is saying if you take the function and do the opposite of the whole thing. So when I see that negative sign in front of the f of x, I'm going to take f of x, which is 2 to the x plus 1, and put a negative sign in front of it. Now, if you type that into Desmos, you can do that, or you can distribute and get negative 2 to the power of x minus 1. And so this is what I'm actually going to type into Desmos to see what that looks like. So if I type that in, negative 2 to the power of x minus 1, you'll notice that in this case I'm looking at the green curve. All right, and a couple things I noticed is that the green curve never touches the x-axis, and it crosses the y-axis at negative 2. So when I'm looking at my answer choices, I'm looking for an answer that matches that green curve. All right, so I know B is showing exponential growth, all right, and this is showing exponential decay. All right, C doesn't look like it. So really it's going to come down to, sorry, A doesn't look like it. C or D. And as I told you guys before, it's never going to cross the x-axis, and in D you can see it cross the x-axis. And it also has to go through 0, negative 2 for the y-intercept. I'll show you again, right? 0, negative 2 for the y-intercept. So that's why C is going to be our answer. Okay, number 6. Now, number 6 gives you a model for how many members for a gym T years after the gym opens. But instead, they want to look at in quarter years. All right, so this is a little tricky, but basically what the formula is if I gave you that formula again, the one that we've been using is 1 plus r to the t. There's another formula that's very similar. It's the same formula, really. That's not as simple, where you do 1 plus r over n, and then t times n, all right? And this is what is called, if you have any compounding. So in this case, because they want to know in quarter years, they're saying take the rate, which is over the entire year, and divide that by 4 in terms of quarters. So I'm going to do still the same 1800 number, but instead of having my rate of 0.02, it's going to be 0.02 divided by 4. And then the power is not just going to be t, it's going to be 4 times t. Okay? So if you were to divide that 0.02 divided by 4, all right, you're going to end up getting 0.005. All right, so right then you'd see the answer, but you also would notice that it has the same power of the 4t, in this case q. So C is the only one that matches. And this is a little tricky. So if you're ever taking a model that's for years and you want to break it down to quarters or maybe monthly, if it was monthly, n would just be 12. So just try to use what the problem is telling you if you have to use this more complicated formula. Okay, number 7. Now, number 7 says we have an exponential function h that has a y-intercept of d, where d is a positive constant. So I immediately crossed out b, because b is not exponential, right? We need to have an exponential function. When I looked at this letter c1, I know that negative x cubed, I know what that looks like, right? And if I throw a number in front of that, all that's going to do is stretch or compress it. It has nothing to do with the y-intercept. So really the question is it a or is it d? Now with d, if you make it a positive constant, right, the problem is that this negative 3 in front, that's going to dictate the y-intercept. So let me show you, for example, why d is the right answer. What I did was I just made up a number for d that's positive. So I used 2 times 3 to the x. Let me show you what that looks like. 2 times 3 to the x power on Desmos, so you can see why that's the answer. I'll delete these. So 2 times 3 to the x. All right, if you look at the one in purple, you notice the y-intercept is at 0, 2, 0, 2, which is the same as that number that I chose. So that's why the answer for this one is D. All right, number 8. Okay, so in this one, they're talking about that the value of the antique, all right, each year it's increasing 10% over its value the previous year. Okay, so exponentially. The estimated value of the antique in dollars 2 years after the purchase is going to be represented by this. So again, if I'm using my formula, that's A times 1 plus the rate, the t power. Now, they're telling you it's 2 years after the purchase. Well, it's going to cost $200 when we bought it. And then 1 plus the rate is 10% over its value the previous year. So that's 1 plus 10%, in this case, squared, so 2 years after the purchase. So if you were to do that, you would write it down as 1.1 squared. But the answer says, okay, what is A? All right, so to get the answer, you're going to have to take 1.1 and square it. So if you go here and type in 1.1 squared, and we want to square it. 1.21 is the answer. So 1.21. All right. Number 9. Now, number 9, I put this one on here. It's not necessarily, I'll just be honest with you, it's not really an exponential or logarithmic question, but I wanted to put it on here because it does talk about the population is increasing and decreasing. So it's not really exponential, but it's still a little tricky. So we've got city X and city Y. All right, and it says they have the same population in 2015. All right, but in 2010 they had different populations, and it says city X's population in 2010 was 120,000. All right, so this is 2010. And in 2015, it says that city X's population over those years increased by 20%. So if you look at 120,000, 10% of that is going to be 12,000. So 20% is 24,000. So when you add that together, you get 144,000. Okay. Now in 2015, they have the same population. So city Y has the same population. So 2016. So in 2010, all right, it's not going to have 120,000 because it says from 2010 to 2015, city Y's decreased by 10%. So this number in 2010 needs to be higher than 144,000. So immediately A and B are wrong because I can't go from 60 or 90,000 and decrease to get 144,000. Okay? Now it's decreasing by 10%. I know that 10% of 160,000 is 16,000. So if you were to subtract 160,000 minus 16,000, you guessed it, you get 144,000. So this is the population of city Y back in 2010. Again, not really exponential, but still talking about increasing and decreasing populations by percentages. Okay, number 10, last one. We have Eleanor, who organized a fundraising event. She invited 30 people. For each of the next 5 years, she invited double the number of people she had the previous year. So 30, 60, 120, 240. Let's see, that's going to be 480. And then I think that should be it, 960. Okay. Now, when this is saying which of these best describes the function, right, if you had to think about this in terms of a function, you'll notice it's not just going 30, 60, 90, 120, 150. It's not just increasing by 30 people each year. She's doubling it each year. So that means she's actually doing something called an exponential function, and it's getting bigger. She's inviting double, so it's increasing. So it's going to be D. This is an increasing exponential function. All right, so hopefully that helps you guys when you get to the SAT questions on your test. Again, it's open notes, so you can even watch this video as you're doing them. The SAT questions are not worth as much as the other ones, so even if you struggle, it's okay. Do your best, and good luck.